Hi, welcome to Honors Chemistry. We're going to be doing sample problems from Chapter 18, Section 1. Hopefully you've already looked at the PowerPoint, which should be on Schoology. This is my kitchen. This is where I'll be coming to you for the sample problems that we're going to do like we would do in class. First of all, I hope you're all okay. I miss you all. I'm sorry for the things that you're missing. But this was new stuff that I thought you still needed for chemistry. So in Chapter 18, we're talking about acids and bases. And section 1 talks about 3 different definitions for acids and bases. So we have the Arrhenius model, which was the first one that we had. And it's the reason why when you know what an acid is, you can kind of identify it because hydrogen always comes first. When we were naming the acids, we knew that there was an acid because hydrogen came first. And then bases, according to the Arrhenius model, they always have hydroxide. So it's really easy to look at the formula or look at the name with the Arrhenius model and tell whether or not it's an acid or a base. So what we're going to do first is I'm just going to review a little bit of how we name the acids and the bases. And then we're going to talk about the second model, which is the Bronsted-Lowry model. And then you're going to have a chance to practice on your own. There's a worksheet that will be due Thursday of this week. So that's what we're going to do today in this video. As a review, if you remember from when we talked about acids before, we didn't call them monoprotic, but that's one of the words that's in the PowerPoint. Monoprotic just means one proton, and when we think about protons, we have to think about hydrogen and hydrogen ion. So a monoprotic ion or acid is pretty easy to name. We learned it before. We called it binary before. So if you had HCl, that was called a binary, or in this case, monoprotic acid. And so we put hydro as the prefix, and then we take the ending off and we put an ic suffix on. So HCl becomes hydrochloric acid. And that only works for the monoprotic or the binary acids. And then we had ones that were like H2SO4. Look, I have a whiteboard here at home, not at school. So H2SO4, that's an acid. And I can tell it's an acid by using Arrhenius because it starts with hydrogen. But if you notice, there are 2 hydrogens, which means it's diprotic, or it's polyprotic, which means more than one hydrogen. And so we're going to name this differently. Also, it's got that polyatomic ion. Now, SO4 is normally sulfate, but in acid world, we take off the 8 and we make it an ic. So this becomes sulfuric acid. Notice there's no hydro in front. Hydro is only for the binary acids or the monoprotic acids. So this is going to be sulfuric acid. Another example, and although this is monoprotic because there's only one hydrogen, we've got that problem of the polyatomic ion again. So this is all review. We've done this all before. We have to look up on our chart, hopefully you have your charts at home, for the polyatomic ion NO3. Okay, so NO3 is nitrate. So once again, just like the sulfate, 8 becomes ic. So this is going to be nitric acid. A difference, looks kind of similar. We have HNO2, but NO2 is not NO3. NO3 was nitrate, NO2 is nitrite. So ITE becomes us, OUS. That's the suffix that we have to add. So this is nitrous acid. So notice the difference. You take the ATE suffix off of the polyatomic ion and you add IC. So this becomes nitric acid. And this NO2 is nitrite, ITE suffix. The ITE suffix becomes us. So this is nitrous acid. And this is all review, like I said before, but in the problems that you're going to do, it doesn't always give you the formula, so you have to write the formula first. So that's just a review on how to name or write the correct formulas for the acids. The bases are even easier, and you've done those before too because we've named ionic compounds. OH is always going to be the end of an Arrhenius acid, so you'll have like magnesium hydroxide, and it's going to be Mg parentheses OH2, and it ends in OH. It's an easy way of telling that it's a base. So that's how we're going to do the Arrhenius definitions. And it'll just ask you to identify them as acids or bases on the practice sheet that you're going to do. The second definition for how to figure out an acid and base is a little bit more specific because some bases don't end in hydroxide and some acids there might be a different definition. And this is called the Bronsted-Lowry model for acids and bases. And this has to do with who gives up a hydrogen and who takes in a hydrogen. It's just you have to have a whole equation. And when you have the whole equation, something is going to donate a hydrogen ion. So once again, the hydrogen with the plus sign, it's a hydrogen ion. It's lost its electron. Or there's going to be another species or substance that's going to accept the hydrogen ion. That's called the base. So according to Bronsted-Lowry, anything that gives up a hydrogen ion, that's an acid. Doesn't matter whether it starts with an H or not. Anything that's going to accept that hydrogen ion, whether it ends in OH or not, that's going to be considered the base. And then we have the things that go with the Bronsted-Lowry acid and the Bronsted-Lowry base, and that's called the conjugate acid and the conjugate base. So when the base accepts that extra hydrogen, on the other side of the equation, it's going to have an extra hydrogen. That's the conjugate acid. It goes with the base. The substance that lost the hydrogen, the stuff that's left over, that's called the conjugate base. And those are going to go together. And I'm going to do several examples like that, starting with easier ones and getting to more difficult ones. So now if my cameraman will please come to the other side. See my little whiteboard? I hope there's not too much of a shine on it. So what you're going to be given is you're going to be given an equation. So we have nitric acid and we have water. And after these two things react, that's what you're going to end up with. Okay, so here's your reactants and there's your products. And you'll be given reactions like this, and they want you to identify the acid, identify the base, identify the conjugate acid, and identify the conjugate base. And then sometimes they want you to group those together. So this is where you have to know the definition. If you just used Arrhenius, this wouldn't work. It would work for this. According to Arrhenius, that's an acid, but that's not a base. That's water. So something has to act like an acid, something has to act like a base in the Bronsted-Lowry world. So what you do is you look and see what happened afterwards. So here we have nitric acid, HNO3. And after the reaction, we're left with the nitrate ion. We're left with a nitrate ion because this gave up its hydrogen. This became that by giving its hydrogen to the water. That's the definition of a Bronsted-Lowry acid. If you give up your hydrogen ion, you're the acid. So this is the acid. Better. There's Bronsted-Lowry acid. Now, what goes with the Bronsted-Lowry acid? It gave up the hydrogen. What's it left with? After the reaction, this is what's left. The hydrogen is gone. This is what's left. This is called the conjugate base. Conjugate is C-O-N-J-U-G-A-T-E, but I'm going to abbreviate it. So this becomes this because it gave up the hydrogen. Well, then by a process of elimination, it's kind of easy to figure out what's going on next. This was water. What did the water become? Well, there's an extra hydrogen here. That's why it got the charge. It took on an extra hydrogen. This we call it in the notes the hydronium ion. So this is the Bronsted-Lowry base. It took on an extra hydrogen.
Bad color.
Bad color. Okay. I want a different color. We'll go with blue. We'll see if you can see blue. This is going to be the Bronsted-Lowry base.
Good color.
Good color. And this is going to be the conjugate acid. And this is how I think of this. They're called pairs. They're called the conjugate pairs. So this was an acid. It gave up its hydrogen. It became this. Notice the charges. You really have to pay attention to the charges. This was neutral. When it gave up that hydrogen ion, it became negative because it had extra negatives. So it has a negative charge. Over here, water was neutral, but water took in that extra hydrogen ion. Now it has a +1 charge, and this is called the hydronium ion. So these two go together. They're called a conjugate pair, and these two go together, conjugate pair. And that's how the Bronsted-Lowry model works. So let's do one more. To remember my colors at work. Okay, this one's a little bit trickier, but it's not too bad. Where's the black one? The black one. Okay. So, once again, sometimes you can use the Arrhenius, but sometimes you can't. And you really have to pay attention to the charges as well. You have to figure out which two go together, and you have to remember the definitions. So we've got hydrofluoric acid. It's a fluorine, hydrofluoric, because it's binary. Then we have the cyanide, polyatomic ion. Those two are going to go together.
this is hydrocyanic acid, and you got a fluorine ion. So we need to label this. We need the acid, we need the base, we need the conjugate acid, and we need the conjugate base. So, which looks like this. This goes with this. Hydrofluoric acid will become the fluorine ion when it loses its hydrogen ion. So that makes this, by definition, that's the acid. When it loses the hydrogen ion, it was neutral. Now it's going to have a negative charge. This is going to be the conjugate base. By a process of elimination, got cyanide. It's got a -1 charge on it. Well, it's going to take that hydrogen. When it takes that hydrogen, it's an ion. +1, -1, it becomes neutral, and it becomes this. This is the hydrogen ion acceptor. Donor, acid. Acceptor, base. When it takes that, it becomes this. This is the conjugate acid. These go together, and these go together. Hopefully, you understand that. There's a whole bunch for you to practice on the worksheet. The last thing that we're going to do deals with if you're given a species and they want you to figure out what's the conjugate acid that goes with the base, or what is the conjugate base that goes with the acid. And I'll give you an example of that. Let's say that in Bronsted-Lowry world, they tell you that's an acid. So in Bronsted-Lowry world, if this is an acid, that means it's going to lose its hydrogen ion. Okay, so it's gone. Goodbye hydrogen ion. So what does that leave? Well, if this is the acid, you're going to be left with a conjugate base. And what would that conjugate base be? Well, if by the definition you're losing a hydrogen ion, then that means that what's left? Well, NO2 is left. That part was easy, but you have to remember the charge. If you're losing a positive ion and this was neutral, this has to be a negative, because +1 -1 takes us back to neutral again. So, by definition, Bronsted-Lowry acid loses a hydrogen, goodbye hydrogen ion, what's left, and then you have to think of the charge. So this is the conjugate base. This acid goes with this conjugate base. And the type of question that they'll ask you is, if you're given this Bronsted-Lowry acid, what is the conjugate base? And you just have to think about the definition, what you'll be left with, and then make the charges work. If we do one that's a little bit harder, because I know how much we love integers, if we have this, and we're told this is an acid, and we want to come up with what is the conjugate base. That means what's left over. Well, by definition, hydrogen's gone. Okay, goodbye hydrogen. What's left? Well, the sulfur is left, but now we really have to think about the charge. This had an overall -1 charge, and you just lost another positive. Well, if you lose another positive, that means that has to have a -2 charge. +1 -2 gives us the original -1. One more time. By definition, Bronsted-Lowry acids lose a hydrogen ion. Hydrogen ions have a +1 charge. If this thing is going to lose another positive, that means it's going to be even more negative. And you can check your answers. You can go back and say, okay, if I put this back with this, I'm back to HS, and then +1 -2 is -1. So this is the acid, and that's the conjugate base. Another thing that they can do is the reverse. They'll give you the base and want to know what the conjugate acid is. So, let's say we have pH3. And they tell us this is a Bronsted-Lowry base. And they want to know what is the conjugate acid. That's what they want to know. Well, you have to know the definition. The definition of a Bronsted-Lowry base says it accepts a hydrogen. Doesn't tell us from where, doesn't matter. We know it's going to accept a hydrogen. Okay, so one more hydrogen. That makes this pH4. But wait, there's a plus sign here. You always have to think about the charge. So this was neutral. Well, you just added a plus to it. That makes it positive. And that's how going from a base to a conjugate acid works. They'll give you the base and tell you, okay, it's going to accept a hydrogen, and this is going to be your conjugate acid. We'll do one more, a little bit trickier. Oops. That should be a familiar polyatomic ion. That's phosphate. It has a -3 charge. We're going to say that this is a Bronsted-Lowry base, and we want to know what the conjugate acid is. Okie dokie. By definition, that means this is going to take on a hydrogen ion. So here comes the hydrogen ion. Okay, HPO4. That's what's going to happen with the letters, with the elements, but what's going to happen with the charge? Well, it was a -3 and you just added one more. So you owe $3 and somehow you came up with $1. That means you only owe $2 more. Integers, that's all. So this is the conjugate acid that goes with the base. Hopefully you understand this. There's a worksheet on Schoology, and it will be due on Thursday, and I'll get those graded. And then if we need more help, maybe we'll set up a Zoom meeting on Wednesday for those of us that need extra help. We'll see how that goes. But with the Zoom meetings, we're going to need permission slips if you're not 18 yet. So anyway, hope you enjoyed this and you don't have any questions, but if you do, you can email me or message me or whatever. Thanks.